Ladies and gentlemen, distinguished guests, and fellow enthusiasts of the cosmos, I am Aman Singh Bogal.
And I am Mhi Sil.
Along with our mentor, Professor Pratia Mam, we have prepared a conference paper titled NASA Nearest Earth Object Classification Using Quantum Machine Learning, a Survey. We are currently fourth year students pursuing Bachelor's of Technology in IT domain from NMIMS Mukesh Patel School of Technology Management and Engineering, Sherpur, Maharashtra. So let's start with a presentation. First, we have an introduction of our paper.
Okay, so first thing that I want to make clear is quantum computers aren't the supercomputer. They aren't the faster version of what we use now. They are something totally different. And that difference is actually the key to understanding why they are such a big deal. Why governments around the world are battling it out to build them fastest. Quantum computers are wild. They are on track to change what we can build and how we understand the world. They are kept at temperature colder than space. This is a literature review paper that we prepared for our main project that aims to classify hazardous objects that are near to Earth. Our research problem statement focuses on information about objects in outer space, including some that are much closer than we could ever imagine. Despite appearing harmless in their distance, at an astronomical scale, these celestial objects could potentially disrupt natural phenomena and pose a threat to Earth. Given this concern, our aim is to explore and understand these objects comprehensively, to assess their potential risk and implications for our planet's safety. To help with this, we are using two types of computer techniques. One is called classical naive Bayes and other is quantum naive Bayes. We are going to test these techniques on a bunch of data to see how they will work. But before we get into technical stuff, we have done a lot of reading about quantum computing, which is a way of doing calculation using really tiny particles. Long time ago, a smart person named Richard Feynman came up with the name quantum computing. He said that with the right kind of quantum machines, we could copy anything in the universe, even the real world. Quantum computing is like a special kind of computers that uses very small things to solve problems. These small things can do special tricks like being in more than one state at a time, and they can work together to solve problem faster. We call these small things qubit.
Now, let's move on to quantum machine learning. This is when we use quantum tricks to make computers learn and solve problems. Machine learning is like teaching computers to do things without giving them exact instructions. There are four ways we can mix quantum tricks with machine learning. The first one is classical tricks with classical data. We use some quantum ideas to help regular computers handle normal data. The next one is quantum tricks with classical data. We use quantum tricks to make regular computer tasks faster and better. The third one is regular tricks with quantum data. We use the regular computer tricks to understand data that comes from the quantum world. The last but not the least is quantum tricks with quantum data. Here we use quantum tricks and quantum data to learn secrets from the quantum world. These ways of mixing things up shows us that quantum machine learning is a big deal. Even though it's still pretty new, it could help us deal with big pile of data and might even give us the chance of how we do things in future. So, as we stand here today, we are looking at a fascinating blend of outer space mysteries and clever computer ideas. Just like planets affect each other's path, we are aiming to follow a path of learning that takes us to new and exciting places. Together, let's journey into the world of quantum machine learning, where the magic of tiny particles meet the smartness of computers, bringing us closer to the exciting discoveries.
Now, before moving ahead in our presentation, we'd like to acknowledge top 5 research papers that really fascinated us while we were researching in this domain. The first is Simulating Physics with Computers. This was written by Richard P. Feynman, and this was one of the first paper written in the field of quantum computing. This paper focuses on simulation of quantum physics through a universal computer. This could potentially lead to modifying physical laws such as considering discrete space and discontinuous time, and might result in experimental anisotrophies.
The next paper is An Introduction to Quantum Computing for Non-Physicists by Elon Reffel and Wolfgang Polak. So, this paper aims to guide computer scientists in understanding the power and difficulties of quantum computing, including quantum cryptography, teleportation, dense coding, and quantum error correction.
Third is evaluation of quantum computing, a systematic survey on use of quantum computing tools. This paper is written by Paramita Basak Upama. This paper basically discusses the progress made in quantum computing and presents a systematic survey of papers, tools, and platforms facilitating quantum computing.
So the next paper was Quantum Computers, a review on how quantum computing can boom AI by Vibhor Chauhan. So this paper explains the quantum computing born from quantum theory and has the potential to revolutionize computation by enabling unparalleled speed and solving complex problems that are currently beyond the capabilities of classical computers and algorithms, making it a powerful tool for the future, especially when combined with artificial intelligence.
Next is IBM Qiskit Toolchain, written by Robert Wheeler. Now, this paper explains that quantum computers, which promises significant speed ups over conventional machines, and are now available through initiatives like IBM Q Experience and Qiskit Tool, allowing researchers, developers, and enthusiasts to access and run experiments on quantum machines.
Now, coming to the tools and libraries. So, while doing our research, we, went through all different companies that are available in the field of quantum computing. And the main players that we identified in this field were D-Wave, IBM, and Google. And after doing a thorough research, we tried to compile and make a difference between all these companies and divide them on the basis of some parameters like business, technological advancement, focus, tools, and other parameters. So the first parameter was business. So D-Wave is a leading company to produce commercial quantum computing systems, softwares, and services, whereas IBM offers quantum systems, softwares, and services for the quantum computing, while on the other hand, Google demonstrates practical realization of quantum computing with Nest systems.
Coming to the next parameter, technological achievement. Now, D-Wave is known for quantum annealing approach and quantum systems like Advantage. IBM developed processors such as Eagle, Osprey, and planned Condor with increasing qubit counts. And Google has achieved breakthrough with processors like Sycamore, performing tasks in seconds that would take classical computers thousands of years.
So the next parameter was focus. D-Wave focuses on installing over 1000 qubits and scalability at the quantum artificial labs, whereas IBM focuses on modular systems and connections between independent processors for scalability. While on the other hand, Google pursues the development of logical qubit for error-free storage of quantum data.
Next parameter was tool. D-Wave offers QB-Solve library, while IBM offers Qiskit library and Google offers Circ library.
Okay, so the next parameter was Moto. So D-Wave provides cloud services, application development tools, and professional services, while IBM is pursuing the development of quantum-centric supercomputers, integrating classical and quantum systems, while Google emphasizes the potential of quantum computing for tackling complex calculations and surpassing classical computing capabilities.
Talking about future work, D-Wave is collaborating with customers like Temporal Defense System, Google, NASA, USRA, Virginia Tech, and the Center for Defense and Intelligence Applications. IBM envisions multi-chip processors like Kookaburra to achieve high qubit counts, and Google is focusing on scalability and commercial readiness of quantum computing.
The next parameter was computational model. So D-Wave uses quantum annealing computational model, whereas IBM uses universal gate computational model and Google uses universal gate computational model.
Coming to research methodology. Now we are diving into the world of quantum computing through a special review. Our goal is to look at all the research and cool things happening in this field. First, we had a plan. We decided what we wanted to learn from our review. Then we looked at lots of books and papers from places like IEEE Explore and Springer Library. We picked the newest ones because we wanted to know what's happening right now. We found out about tools and libraries that help with quantum computing. These are like tools in a toolbox that helps us do our quantum computer work. We put all this information together to make a big picture of what's going on in quantum computing today. We also organized the information into groups based on the different things we learned. This helped us compare them and see what they are good for. In a nutshell, our review is like a treasure map that shows you the exciting things happening in quantum computing. It's like a sneak peek into the world of tiny, super powerful computers.
Now, coming to the conclusion, to sum it up, our literature paper review on quantum computing aimed to provide a comprehensive analysis of existing research and development in the field. By applying classical Naive Bayes algorithm and quantum Naive Bayes algorithm to NASA Nearest Earth Object dataset, we aim to evaluate their performance in classifying objects of potential risk to Earth. Okay, lastly, we have the references that we have used for making this paper. There were around 22 papers that we read, and some other were blogs and articles on quantum computing that have been mentioned over here. Lastly, we would like to thank you for coming along the way and being patient with us. Thank you.